Good day, viewers. Today we are going to take the topic change of subject of the formula. And firstly, what does the formula mean? A formula is simply an equation that you cannot solve until you replace the letters with their values. It is known as a literal equation. So a formula is any equation that you can't just solve until when each variables is given their numbers. So to change the subject, that means to change one variable with the other variable. We apply some rules. And what are the rules we are to apply? The first is that we add the same variables to this side. The second is we subtract the same variable from both sides, that's from the right hand side to the left hand side. We multiply both sides by the same variables and we divide both sides by the same variable. So I want you to pick up your writing materials, your pen, your calculator. We'll be right back. Welcome back. This is an example on change of subject of formula, which we also known as transposition of a formula. They are the same thing, meaning changing a variable to the other variable. Now, this is an example which follows that the formula for traveling at a uniform acceleration is given by t equals to 1 over a, open bracket, square root of u squared plus 2ax minus u. Take notice, this minus z is not part of this square root. It's standing as a variable on its own. So now from this formula, we are to show that x, which will be a new subject, equals to 1 over 2 at squared plus ut. This looks like an equation in physics, which we know as equation of motion. So we are to make this formula look exactly like this. It's not that hard. So let's crack it as a listing solution. So I have t equals to 1 over a square root of, open about square root of u squared plus 2ax minus u.
Hi, if you have not subscribed to this channel, you can do so in 5 seconds. 5, 4, 3, 2, 1. And don't forget to hit the notification button.
You want to make this formula look exactly like this. So the first thing is you cross multiply. This equation can be written as t equals to 1 multiplied by all these. I have it as square root of u squared plus 2as minus u all on a. Now this has been changed to this. I just use this one to open this and write it in the normal way it should be. So when I cross multiply, here I'm going to have a multiplied by t, which is known as at, equals to square root of u squared plus 2ax minus u. So from this, I'm to collect like terms by bringing this minus u here to the other side. So I'm going to have at plus u. Then here I'm going to have square root of u squared plus 2as. Now if you look at it, square root is part of this variable. Now, if you want to eliminate square root, what are you going to do? You square both sides. So squaring, that's the next step to take, squaring both sides. So I'm going to have at plus u all squared equals to square root of u squared plus 2ax all squared. So it will be easy for me to eliminate my square root. So yeah, my square is going to eliminate my square root. So here I have at plus u all squared. Then at this my right hand side, I'm going to have u squared plus 2ax. Now, as you all know, your expansion, that's if you have at plus u squared, that's if you have something like a plus b squared, you have to make it like a plus b under algebraic identities. So this can be written in this can be written in this form. So here I'm going to have at plus u at plus u equals to u squared plus 2ax. So let's open this bracket by using these terms to multiply this term. So here I'm going to have x squared t squared 8 multiplied by u. I'm going to have u at plus u multiplied by at. I'm going to have u at, then plus u multiplied by plus u. I'm going to have u squared. Everything is equals to u squared plus 2ax. So what's next? I'm to bring this u to this point so that my 2ax can stand on its own. So I can have it as 2ax equals to a squared t squared. Don't forget this has 1 at their front. So this and this are the same. We add them together. So I'm to have plus 2uat plus u squared. Don't forget this u is coming. I'm collecting like terms. It comes to this other side. I'll have it as minus u squared. So minus u squared is going to cancel positive u squared. So here I'm going to have 2as. This can be written as at all squared. It's still the same thing. I just try to simplify it. So a squared, t squared can be written as at squared plus 2uat. So now you see that we are getting close to our answer. What is disturbing x that will make it look like this? We have 2a. So we have to divide both sides by 2a. Dividing this by 2a, you have 2ax over 2a. Then this other side by 2a, you have at all squared plus 2uat all on 2a. Gradually, we are coming close to our answer. So 2 divides 2, a divides a. Now x. I've gotten my first variable, which is x, which I'm asked to make the subject of the formula, equals to. Now I can split this equation into two. Look at it, I can split it like a t all squared over 2a plus 2uat all on 2a. These and these are still the same. I just trying to simplify it. So don't forget that these, we have two a's here. So 1a is going to cancel 1a. So our final answer, which is x, equals to, here we are going to have 1 over 2 at squared, which looks like this. Then 2 is going to divide 2, a is going to divide a. Then here we are left with what? Ut, which is our final answer. So we have transposed the first formula to look like this. We have shown that x is actually 1 over 2 at squared plus ut squared. Thank you.